Hey folks, Thomas here. Welcome back to Mears Lab. In today's episode, we're going to take a look at how to add an EQ to a Fender Champ 5F1 tube guitar amplifier. I made this video for anybody out there that's interested in building their own vacuum tube amplifiers and wants to learn a little bit more about EQ. I love this mod because it's perfect for the Fender Champ and also pretty much any other tube amplifier that only has volume control. Here is the schematic for the Fender Champ 5F1 amp. I'm not going to go through this all the way because I've already done that in another video. In that video, I go through every part on the schematic one by one and explain what they all do. I'll put a link down in the description so you can check that out later if you're interested. Okay, so down here at the bottom of the schematic, this is the power supply right here. That would be like your power plug. This is the power transformer and the rectifier tube right there. And then this is the power supply caps right there, 1, 2, 3. And then up here, this is our input right here. And then signal would go in here, like we plug our guitar in right there, and then go into the preamp tube right here, the 12AX7. And let's keep in mind that the 12AX7 is dual triode. That means it's kind of like two tubes in one. So there's one side of it right there, and there's the other side. And that would be kind of one tube right there. They just kind of split it apart so it's easier to read on the schematic. And here is our power tube right there, the 6V6. And then there would be an output transformer right here, and then our speakers right over here. Here's how the signal would normally go through the amp. It would go in the input right here, through that resistor, and into the grid, then out of the plate of the first side of the 12AX7, through this little cap here, and then through our volume knob right here. And then it would go into the grid of the second side of the 12AX7 preamp tube, come out of that plate, go through this other little cap right here, and then into the grid of the 6V6 power tube. And then it would come out of the plate of that and go through the primary winding of the output transformer, then come out of the secondary. A little bit of the signal is going to come back here through this negative feedback resistor right here into the cathode of the second side of the 12AX7 preamp tube. And finally, the sound will come out of the speaker. Hopefully. I want to make this schematic a little simpler to look at, so I'm going to eliminate some of the stuff that we don't need on it, like the power supply and the output section right here and the power amplifier. We don't really need any of that, so let's get rid of that. There, that's a lot better. That's much more simple now. Okay, so we got rid of all that other stuff. This line right here is the B+. It goes through a 100K resistor and is connected to the plate of the first side of the 12AX7 tube. Here's what we're going to do. We're going to remove this 0.02 microfarad capacitor, and that's where our EQ is going to go. Let's do that here now. There. After you do that, it should kind of look a little bit more like this. So let's just keep in mind there's our B+ once again there. And this is the same tube right here. I've just kind of spread them way apart to make it look a lot more simple. Okay? So our signal is going to come from the plate. It's going to go into the EQ right here. And then it's going to go into the volume knob right here. And then it'll go to the grid of the second side of the 12AX7 tube. Here's a look at the EQ circuit that we're going to use in today's video. It's from a modern Fender Princeton amplifier. The neat thing about it is that Fender's pretty much used the same circuit for all of the EQs in all of their tube amplifiers that they've ever made. There might be a few changes in values here or there, but for the most part, it's basically the same EQ in all of their amplifiers. Here's how the EQ works, or at least my understanding of it. The signal comes in this point right here from the plate of the previous gain stage, and it goes in through here, and it goes through this small little cap here, just 250 picofarad, goes through that, and then it goes into this pot here, and that's our treble pot right there. So it goes into one side of that, and then the signal comes out of the wiper, and that signal actually carries our full guitar signal, even though that's the treble pot, because the other side of that pot is what carries the bassy side of the signal. And here's how they do that. The signal gets split up into two parts here. The top line right here, That creates a high-pass filter through this small little cap, and that just lets the treble frequencies through. And if we follow this other line here, it goes through this 100K resistor, and what that is called is a slope resistor. What it does is it sort of balances the amount of bass in the signal compared to the amount of treble, so it sounds right for the guitar. Then the signal comes down here, goes through this 0.1 microfarad cap, and then it goes into the bass potentiometer right here. And at that same junction, it's connected to the other side of the treble pot. So when you turn the treble pot, you literally are choosing how bassy or trebly you want the signal to be. Because one side of it's all bass and one side of it's all treble. When you adjust the bass pot and you turn it up, it creates less resistance between the wiper and this top lug right here. And that has the effect of increasing the amount of bass in the signal. When you turn the knob counterclockwise, what's going to happen is it's going to create more resistance between the wiper and that top lug, and that's going to lower the amount of bass in the amplifier. If we follow the signal down this line here, it also goes through this 0.047 microfarad cap, which goes over here and is connected to the other side of the bass pot, and then is also going through a 6.8K resistor, which goes to ground. And you can think of that as the mid control. On a Fender Princeton amp, they have the mids preset at this value right here for 6.8K. However, you could go and adjust this value and you can make that whatever you want, and that would either give you more or less mids. Or another thing you could do is remove this 6.8K resistor and add a pot there instead, and then you'd have a control for your mids. And what you'd probably do is add a 10K pot so that when it's at its halfway position, it's set to about 5K. So if you wanted to have it set just like a Fender Princeton, then you would take that 10K pot and you would normally have it set at probably 1 or 2 o'clock, which would give you somewhere around 6.8K, which would be like the factory setting of a Princeton reverb. So that's basically all there is to the Fender EQ. There's just 3 capacitors and 2 resistors and 2 pots. That's all that there is to it. Here's what it looks like after we add the EQ into the preamp circuit. You can see I've got it added right here in the middle, and some crude green wires drawn here that connect the plate into the EQ and the output from the EQ into the volume control right over here. Okay, let's follow the signal as it makes its way through the amp now that we've added an EQ to it. First, it goes in through our input, through the 68K grid stopper resistor here, into the grid of the first preamp gain stage right here. Then it gets amplified, comes out of the plate, goes into our EQ, and gets all EQ'd in here, and now our guitar sounds awesome. And then it comes out, goes through a crude green wire right here, and into our 1 meg volume pot, and then out of the wiper, and then into the grid of the second preamp tube gain stage right here. And then out of there into the 6v6, and so on and so forth. Okay, now let's go build one over on the bench. Here's all the parts that we're going to use. There's just 3 capacitors, 2 resistors, and 2 potentiometers. The first capacitor is a 104. That's a 0.1 microfarad. The next one is a 473, which is 0.047 microfarad. This is the treble cap, and the schematic calls for a 250 picofarad cap, but I don't have any of those right now. This is a 100 picofarad, and it'll still work just fine. It just won't sound quite as bright as the 250 picofarad cap would. If I were to install this circuit into an amp, it would sound a little darker than normal. Here's the 100K slope resistor. And here is a 4.7K resistor that I'll use for the mid-range position instead of a 6.8K, because I don't have any 6.8K resistors handy at the moment. And here's the 2 pots that we're going to use. They're exactly the same. Both of them are A, which is an audio taper style pot, and 250K. I'm going to start with the 0.1 microfarad cap, the 0.047 cap, and the 100K resistor. Make a little hook at one end of this resistor. first thing I need to do is just spread these like that. Same with this one. So I'm going to go make a little hook there. And I'm going to do the same on this one. But I'm going to make sure it's facing the opposite way. We'll go like that. Okay, now we'll just trim those. I'm trimming these to leave it about 180 degrees of the hook there. So it'll all go together sort of like that. I'm going to mark which one of these is which, so we know. It's bass, and there's treble. I need one short little length of wire to connect the two pots together. I need another one for the input, and another one for the output too. We need to get this mid-range resistor trimmed up. I need to connect the 0.1 microfarad to the wiper in the input, which is this one over here, and I need to connect the 0.047 to that one over there. I'm going to install them like this, like that, there, okay? And then I'm also going to take this lead and I'm going to move it over here so that it goes through the input here, because normally you would connect the input to the wiper on the bass pot. And then this mid-range resistor, that's going to also get connected to the same spot. Here's the 0.047, and then we're going to ground this resistor to the body of the pot. Okay, well, here it is, folks. It's all finished. Here's the treble pot, and here's the bass pot over here. So our signal would come from the plate into this point right here, this junction, and then it goes to the treble cap into the treble pot right here, and there's the wiper for the treble pot right there, and that would be the output that goes to the volume pot right there. Okay, and then the bottom of the treble pot is connected to the input side of the bass pot. And if we go back here to where the signal comes into it, we go through this 100K slope resistor, and then the 0.1 microfarad cap is connected to the wiper and the input right here, and then the 0.047 cap right here is connected to the other side of the bass pot, and that is also connected to ground through this 4.7K resistor. Yeah, so you can see there's not too much to it. Just 3 caps, 2 resistors, a couple pots, a couple of wires. That's all that there is to it right there, folks. Well, folks, that wraps up today's video. If you enjoyed it, then don't forget to hit the like button, and you can always subscribe to the Mears Lab channel for more videos just like this. Thank you very much, and I'll see you next time.